There is an image carved on a sarcophagus in Mexico that has divided researchers for 50 years. To archaeologists, it shows a king descending into the underworld. To millions of others, it shows something impossible. A man at the controls of a machine, hands on levers, feet on pedals, flames shooting from below. The ancient astronaut theory claims the Maya received help from beings beyond Earth. Mainstream science says that is ridiculous. The Maya did it themselves, but here is what both sides agree on. The Maya tracked the stars with impossible precision. They built cities we are only now discovering. They developed mathematics that surpassed anything in Europe for 1,000 years. Someone did something extraordinary in those jungles. The question is who, and the answer may be more unsettling than either side wants to admit. But before we begin, do not forget to subscribe, and if you truly enjoy these videos, please leave a like. Let us begin. What if everything you thought you knew about ancient civilization was wrong? What if the jungles of Central America hide cities larger than London? What if a people who supposedly had no contact with the outside world built astronomical observatories more precise than anything Europe would create for another 1,000 years? What if their calendar predicted cosmic events we're only now beginning to understand? And what if, buried in the symbolism of their art, there are images that some believe show technology that should not exist? This is the story of the Maya, not the simplified version from your textbook, the real story. The one that archaeologists are rewriting right now, with lasers that see through jungle canopy. The one that challenges our assumptions about what ancient humans could achieve. The one that asks uncomfortable questions about where their knowledge came from. We will walk through cities that were lost for 1,000 years. We will decode calendars that track time across millions of years. We will examine the tomb of a king whose sarcophagus lid has sparked decades of debate about ancient contact with something beyond this world. And we will confront the latest discoveries that suggest the Maya civilization was far larger, far older, and far more mysterious than anyone imagined. The jungle is finally ready to share its secrets. Let us step inside. Chapter 1. The Jungle Speaks, Guatemala, the Piton region, 2018. A small aircraft cuts through humid air above an unbroken sea of green. Below, the jungle stretches to every horizon. Trees crowd together so tightly that the forest floor has not seen direct sunlight in centuries. Somewhere beneath that canopy, hidden by vegetation and time, lies one of the greatest archaeological discoveries of the 21st century. The plane carries no cameras in the traditional sense. Instead, it is equipped with LiDAR technology, light detection and ranging. The system fires laser pulses toward the ground at a rate of hundreds of thousands per second. Most of those pulses hit leaves, branches, the thick tangle of tropical growth, but some slip through, some find their way to the forest floor, and when they do, they reveal what the jungle has been hiding for over 1,000 years. The data comes back to researchers at the Preclassic Foundation, a Guatemalan organization dedicated to preserving cultural heritage. What appears on their screens stops them cold. Cities. Not small ceremonial centers, not isolated temple mounds. Cities. Vast urban networks with pyramids, palaces, roads, and agricultural systems stretching across the landscape. Defensive walls and fortifications suggest warfare on a scale never before attributed to the ancient Maya. Irrigation channels and terraced hillsides indicate intensive farming that could have supported millions of people. In a single survey, the LiDAR data revealed more than 60,000 previously unknown structures. 60,000, the number is almost impossible to process. Decades of ground-based archaeology in the region had identified perhaps a few thousand. Now, in weeks, that number multiplied by a factor of 20. The implications were staggering. The Maya lowlands, long thought to have supported a population of perhaps 1 to 2 million people at their peak, now appeared to have been home to 10 million or more. This was not a scattered collection of city-states separated by empty jungle. This was a continuous, interconnected civilization that had transformed the landscape on a scale comparable to ancient Egypt or Mesopotamia, and the world had missed it entirely. How does something this large stay hidden? The answer lies in the nature of the jungle itself. The Piton is not a forgiving environment. Annual rainfall exceeds 60 inches. Temperatures hover near 90 degrees Fahrenheit year-round. Vegetation grows with almost aggressive speed. A cleared field left untended will be reclaimed by forest within a decade. An abandoned city will vanish beneath the canopy within a century. The Spanish conquistadors who arrived in the 16th century found the Maya cities already swallowed by green. They built their missions and colonial towns on the coast and in the highlands, barely penetrating the dense interior. The jungle kept its secrets. For 500 years that secret held. Explorers occasionally stumbled upon ruins. John Lloyd Stephens and Frederick Catherwood famously documented sites like Copan and Palenque in the 1840s, their illustrated accounts igniting European fascination with Maya ruins. But even these intrepid travellers saw only fragments. They cleared vegetation from temple facades, sketched what they could see, and moved on. The full extent of Maya urbanism remained invisible. Traditional archaeology is slow, expensive, and physically brutal in jungle terrain. Researchers must hack through vegetation, contend with insects, snakes, and disease, and can only survey what they can physically reach. A team might spend an entire field season mapping a single plaza. The notion of surveying hundreds of square miles seemed impossible. LiDAR changed everything. The technology was originally developed for military and industrial applications. It found use in surveying terrain, measuring distances, and creating three-dimensional maps. Archaeologists began experimenting with airborne LiDAR in temperate environments, using it to find subtle features in European forests or to map medieval field systems beneath modern vegetation. But the Maya jungle represented the ultimate test. Could LiDAR penetrate tropical canopy dense enough to block 90% of sunlight? The answer, it turned out, was yes. The sheer volume of laser pulses meant that enough would slip through gaps in the leaves to build a detailed picture of the ground surface, and that picture was revolutionary. The 2018 survey covered more than 800 square miles of the Piton. It revealed not only individual structures but entire systems of infrastructure. Roads connected major centres. Some of them raised causeways built to stay above seasonal flooding. Reservoirs collected rainwater for the dry season. Defensive walls protected urban cores. Agricultural terraces climbed hillsides that appeared from the air to be virgin forest. Most striking was the evidence of interconnection. The Maya lowlands had long been understood as a patchwork of competing city-states, each ruled by a divine king, frequently at war with neighbours but fundamentally independent. The LiDAR data suggested something more complex. The infrastructure implied coordination. The defensive systems implied threat perception across vast areas. The agricultural intensity implied central planning. This was not a collection of villages that happened to share a culture. This was a civilization with the organizational capacity to reshape its environment on a continental scale. The discovery forced archaeologists to reconsider everything they thought they knew. Population estimates had to be revised upward, dramatically. The Maya collapse, that mysterious abandonment of the lowland cities around the 9th century, became even harder to explain. How do 10 million people vanish? Where do they go, and why? The LiDAR findings also reopened questions about Maya origins. If the lowland civilization was this large and this sophisticated, how did it begin? What were the first Maya cities? How old were they? And what allowed a Stone Age people, lacking metal tools, draft animals, or the wheel, to build something that rivaled the great civilizations of the Old World? Some of those questions have conventional archaeological answers. Others venture into territory that mainstream science considers speculative at best. But the LiDAR data had made one thing clear. The Maya were not a minor New World curiosity. They were one of humanity's great civilizations, and we are only beginning to understand what they achieved. To grasp the scale of Maya accomplishment, we need to go back. Not to the classic period that most people think of when they hear the word Maya, not to the famous cities of Tikal and Palenque that flourished between the 4th and 9th centuries. We need to go earlier, much earlier, to a time when Rome was a village of mud huts on the Tiber, when the Parthenon was still centuries in the future, when the Great Wall of China had not been imagined. We need to go to El Mirador. El Mirador sits deep in the Guatemalan jungle near the border with Mexico. Reaching it requires either a helicopter flight or a 5-day trek through some of the most challenging terrain in the Americas. There are no roads, there is no infrastructure, just jungle and ruins, and those ruins are immense. The central complex of El Mirador includes the La Danta Pyramid, which rises 230 feet above the forest floor. By volume, it is one of the largest pyramids ever constructed anywhere on Earth. Its base covers an area comparable to the Great Pyramid of Giza. Its mass exceeds that of most ancient structures outside of Egypt. But here is what makes El Mirador genuinely shocking. It was built around 600 BCE. The classic Maya period would not begin for another 1,000 years. The famous cities that tourists visit today, Tikal and Chichen Itza and Uxmal, all came later. El Mirador was the capital of a preclassic civilization that mainstream archaeology barely acknowledged until recently. The site was first identified in the 1920s, but its size and significance were not recognized for decades. The jungle was too thick, the location too remote. Early surveys underestimated the scale of the ruins. It was not until sustained excavations began in the 1970s, and especially after LiDAR surveys in the 2000s, that El Mirador revealed its true nature. The city was not alone. LiDAR and ground surveys have identified dozens of preclassic centres in the Mirador Basin, connected by raised causeways that allowed travel during the rainy season when the lowlands flooded. This was an organised state, or perhaps a network of allied states, operating at a level of complexity previously thought impossible for the Americas at that time. The architecture at El Mirador shows sophisticated engineering. The pyramids were not simple piles of rubble faced with stone. They were carefully designed structures with internal drainage systems, precisely cut limestone blocks, and elaborate sculptural programs. The facades featured massive stucco masks depicting deities and supernatural beings, some of them 2 stories tall. These are not the products of a simple society. They required organised labour on a massive scale. They required architects and engineers capable of planning structures that would take generations to complete. They required surplus food production to free workers from agriculture. They required political authority capable of commanding that labour and maintaining it over decades or centuries. How did the Maya achieve this, and where did the knowledge come from? Conventional archaeology offers a developmental narrative. The Maya emerged from earlier Mesoamerican cultures, gradually developing more complex societies through a process of agricultural intensification, population growth, and social stratification. Writing, astronomy, mathematics, and monumental architecture all evolved over time, building on earlier traditions, but there are puzzles. The preclassic Maya seem to appear with remarkable sophistication already in place. The earliest known Maya writing dates to the 3rd century BCE, and it is already a complex script capable of recording historical events, astronomical observations, and religious texts. Where are the simpler precursors? Where is the developmental sequence that leads to this level of achievement? The same question applies to Maya, astronomy, and mathematics. By the Classic period, the Maya were tracking the cycles of Venus with an error of less than 2 hours over 5 centuries. They had calculated the length of the solar year with greater accuracy than the European calendars of the same era. They used a positional notation system with the concept of zero, a mathematical innovation that Europe would not adopt until the Middle Ages. Did the Maya invent all of this independently? Did they inherit it from earlier Mesoamerican cultures like the Olmec? Or is there another explanation, one that conventional science is reluctant to consider? These questions hover at the edge of Maya studies. Most professional archaeologists dismiss them as pseudoscience, products of cultural arrogance that refuses to accept that indigenous peoples could achieve great things without outside help. And there is merit to that criticism. The ancient astronaut hypothesis has often served as a vehicle for racism, denying credit to non-European civilizations by attributing their accomplishments to extraterrestrial intervention. But the questions persist, not because the evidence for ancient contact is strong, but because the Maya remain genuinely mysterious. Their origins are murky, their achievements are extraordinary, and their own mythology is filled with references to beings from the sky, to ancestors who came from the stars, to knowledge that was given rather than discovered. We will explore those mythologies later. We will examine the controversial imagery that has fueled decades of speculation. We will ask whether there is any legitimate evidence for contact with non-human intelligence, or whether the Maya story is fully explicable in human terms. But first, we need to understand what the Maya actually accomplished. The cities, the calendars, the astronomical knowledge, the mathematical systems. Only by grasping the scale of their achievements can we meaningfully ask where those achievements came from. The jungle has revealed its cities. Now we must understand what those cities meant. In the next chapter, we will travel to the great Preclassic centers, to the origins of Maya civilization, to the moment when something extraordinary emerged from the forests of Central America, something that would track the stars across millennia, something that would build pyramids to rival Egypt, something that would vanish almost completely, leaving only stone and mystery behind. The Maya did not simply live in the jungle. They conquered it. They reshaped it. They made it their own. And then, for reasons we are still struggling to understand, they walked away. The question is why, and the answer may be more unsettling than we expect. Chapter 2. Cities older than Rome. The year is 600 BCE. In Italy, Rome is a cluster of villages on 7 hills, ruled by Etruscan kings and centuries away from becoming an empire. In Greece, the city-states are beginning their rise, but the Parthenon will not be built for another 150 years. In China, the Zhou dynasty is fragmenting, and the great philosophies of Confucius and Laozi are just emerging. In India, the Buddha is perhaps a young man, or perhaps not yet born, and in the jungles of Central America the Maya are building pyramids, not small ceremonial mounds, not simple earth platforms, pyramids, massive structures of limestone and rubble, faced with carved stone and painted stucco, rising above the jungle canopy like mountains made by human hands. At El Mirador, the La Danta complex reaches a height of 230 feet. At nearby Calakmul, pyramids pierce the sky. At Nakbe, the oldest known monumental Maya architecture dates to the 8th century BCE or earlier. These are not the famous cities. Tourists do not visit El Mirador. There are no hotels, no buses, no gift shops selling replica calendars. The pre-classic Maya remain largely unknown to the public, overshadowed by the classic period cities that came later. But the pre-classic was the foundation. Everything the Maya would become, everything that made them one of humanity's great civilizations, began here, in these jungle cities that predate Rome. To understand what the Maya accomplished, we need to understand what they were working with, and what they were working with was almost nothing. The Maya lowlands are not a hospitable environment for civilization. The soil is thin and quickly exhausted. There are no navigable rivers to speak of, no natural harbours, no easy routes for transportation. There are no metal deposits. The Maya would work copper and gold in later centuries, but only through trade with distant regions. In their heartland, they were a Stone Age people in the strictest sense. Their tools were made of stone, bone, and wood. They had no draft animals. The Americas lacked horses, oxen, and donkeys. Everything that needed to be moved was carried by human muscle. Every stone that went into those pyramids was cut, shaped, and placed by hand. Every load of plaster was mixed and carried in baskets. The logistics were staggering. They did not use the wheel for transportation. The wheel was known in Mesoamerica. We have found wheeled toys, but it was never applied to carts or wagons. Without draft animals, wheeled vehicles would have been of limited use anyway. Everything moved on human backs, along footpaths cut through the jungle. And yet, they built cities, they built pyramids, they developed writing, mathematics, and astronomy to levels that rivaled or exceeded the old world. They created a calendar system of extraordinary sophistication. They tracked the movements of Venus, Mars, and the Moon with precision that would not be matched in Europe for 1,000 years. How? Conventional archaeology offers several explanations. The first is agriculture. The Maya developed intensive farming techniques that could support large, dense populations. They drained swamps and created raised fields for cultivation. They built terraces on hillsides to prevent erosion. They managed forests, encouraging useful species and suppressing competitors. They practiced a form of agroforestry that modern environmentalists are only beginning to appreciate. The LiDAR surveys revealed the scale of this agricultural transformation. What had appeared to be virgin jungle was actually secondary growth covering ancient field systems. The Maya had reshaped vast areas of the lowlands for food production. Canals channeled water, reservoirs stored it for the dry season. The landscape was engineered. This agricultural productivity freed labour for other tasks. If you can produce enough food with 80% of your population, the other 20% can become builders, priests, artisans, administrators. Specialization becomes possible. Cities become possible. The second explanation is social organization. The Maya developed hierarchical societies ruled by divine kings who claimed descent from gods, and ancestors. These kings commanded labour tribute from commoners. They organised the construction projects, the agricultural works, the military campaigns. They created the political structures that made coordination possible. Maya inscriptions from the classic period give us detailed records of royal dynasties, warfare and ritual. The kings were called Kuhulajau, divine lords. They were intermediaries between the human world and the supernatural. Their blood was sacred. Their power was absolute. But how far back does this system go? The inscriptions come from the classic period, from the 4th century onward. The pre-classic cities are older than the inscriptions. We must infer their political organisation from architecture and archaeology. The presence of massive pyramids suggests powerful rulers who could command labour. The standardisation of architectural styles across different sites suggests some form of integration. But the details remain murky. The third explanation is trade. The Maya were connected to wider Mesoamerican exchange networks from an early date. Obsidian, a volcanic glass used for cutting tools, came from highland Guatemala, hundreds of miles from the lowland cities. Jade, the most precious material in Mesoamerican culture, came from the Motagua Valley. Cacao, the source of chocolate and a form of currency, grew in specific ecological zones and was traded widely. These trade networks connected the Maya to other cultures. The Olmec civilization, which flourished along the Gulf Coast from about 1500 to 400 BCE, may have influenced Maya development. Olmec art features many motifs that would later appear in Maya iconography. Olmec sites show evidence of sophisticated ritual practice, and possibly early writing. Some researchers believe the Maya inherited key cultural elements from the Olmec. Others argue for independent development. The debate continues, but the trade networks are undeniable. The Maya were not isolated. They were part of a Mesoamerican world. These explanations are powerful. They account for much of what we observe. Agriculture plus social organization plus trade equals civilization. The formula works. But there are still puzzles. The speed of Maya development is striking. The earliest Maya villages date to around 1900 BCE. By 600 BCE, the Maya were building some of the largest structures in the ancient Americas. That is a span of roughly 1300 years. In comparative terms, that is fast. Egyptian civilization took much longer to reach monumental scale. Mesopotamian development was similarly gradual. The Maya seem to have taken a shortcut. Not in a supernatural sense necessarily. Perhaps they were building on earlier developments that we have not yet discovered. Perhaps the Olmec influence was more significant than currently recognized. Perhaps there are foundational sites still hidden under the jungle, or perhaps, as some alternative researchers suggest, the Maya received assistance, knowledge transferred from an unknown source, technology, or at least concepts that accelerated their development. This is the ancient astronaut hypothesis, and we will examine it in detail later. For now, let us note that the speed of Maya development is unusual and requires explanation. Another puzzle is the astronomical knowledge. By the classic period, the Maya had calculated the length of the solar year as 365.2420 days. The modern value is 365.2422 days. The Maya were accurate to within about 30 seconds per year. How did they achieve this? Not with telescopes, not with precision instruments, with the naked eye, counting days, watching the sun rise and set against stone markers, generation after generation. The same precision applied to other cycles. The Maya tracked the synodic period of Venus, the time between successive appearances as the morning star, with an error of less than 2 hours over 584 days. They knew the cycles of Mars. They predicted eclipses. This knowledge was not decorative. It was integrated into Maya religion, politics, and warfare. Kings timed their actions to astronomical events. Temples were oriented to celestial alignments. The calendar was the organizing principle of Maya life. Where did this astronomical tradition originate? The pre-classic Maya clearly had some form of astronomical practice. The alignment of buildings at El Mirador and other early sites suggests celestial observation. But the full flowering of Maya astronomy appears in the classic period, when we have written records and detailed calculations. Did the Maya develop this knowledge independently? Did they inherit it from the Olmec or some other predecessor culture? Or is there another source, one that conventional archaeology does not acknowledge? Let us set that question aside for now, and focus on what we can see. The pre-classic cities. El Mirador is the largest, but it is not alone. The Mirador Basin, a roughly 40 by 25-mile area in northern Guatemala, contains dozens of preclassic centres connected by raised causeways called sac biob. These causeways were engineering achievements in themselves. Built of limestone rubble with plastered surfaces, they stretched for miles through swampy terrain, allowing travel during the rainy season when lower ground flooded. The sac biob connected El Mirador to Nakbe, one of the oldest known Maya cities. Nakbe shows monumental architecture dating to the 8th century BCE. Platforms, plazas, and pyramids appear in a recognizable Maya style. Stone masks depicting deities adorn the building facades. This is not a primitive village. This is a city, or something approaching a city, centuries before the preclassic fluorescence at El Mirador. What was happening at Nakbe in the 8th century BCE? We do not fully know. The site has been excavated, but the earliest levels are difficult to reach and interpret. What we can say is that Maya urbanism did not spring fully formed from nothing. There was a developmental sequence. Nakbe and sites like it represent an early phase, followed by the massive construction projects of El Mirador and its peers. The El Mirador fluorescence lasted roughly from the 6th century BCE to the 2nd century CE. During this period, the city was one of the largest urban centres in the ancient Americas. Population estimates are difficult, but researchers suggest that the greater El Mirador area may have supported several 100,000 people at its peak, and then it ended. Sometime around the 2nd century CE, El Mirador was largely abandoned. The Great Pyramids fell silent, the causeways grew over, the jungle began its slow reclamation. By the time the Classic period began, around the 4th century, El Mirador was a ruin. Other cities, Tikal, Calakmul, Palenque, would rise in its place. Why did El Mirador fall? This is one of the great mysteries of Maya archaeology. Various theories have been proposed. Environmental degradation is one. The intensive agriculture that supported the city may have exhausted the soil. Deforestation for construction and lime plaster production may have triggered erosion and altered local climate. Political collapse is another possibility. Perhaps El Mirador was defeated by rivals. Perhaps internal conflict tore the society apart. Perhaps the ruling dynasty lost legitimacy. We have no inscriptions from this period, so we cannot read the political history directly. Climate change may have played a role. Paleoclimate studies suggest that the Maya lowlands experienced periodic droughts. A severe drought at the wrong moment could have destabilized a society dependent on regular rainfall for agriculture and drinking water. Some alternative researchers see the abandonment of El Mirador as evidence of a more dramatic event, a catastrophe of some kind, a departure rather than a collapse. The Maya, they suggest, were not simply fleeing environmental problems or political chaos, they were leaving for reasons we do not yet understand. This interpretation is speculative. Mainstream archaeology does not support it. But the mystery remains. El Mirador was one of the greatest cities of the ancient world. It was abandoned. The jungle swallowed it, and for 2,000 years it remained hidden. The pattern would repeat. The classic Maya cities that rose after El Mirador would also be abandoned. The 9th century collapse would empty the lowlands of their urban populations. The jungle would reclaim those cities too. Something about Maya civilization seems inherently unstable. Great fluorescence followed by sudden decline. Construction followed by abandonment. Complexity followed by simplification. Is this a failure of the Maya system, or is it something else? A choice, perhaps? A cycle? A pattern that we, with our linear assumptions about progress, cannot easily comprehend? The Maya viewed time differently. Their calendar was not a simple count from a starting point to an indefinite future. It was cyclical. Periods began and ended. Ages came and went. Creation itself was not a unique event, but something that had happened before and would happen again. Perhaps the Maya built their cities knowing they would be abandoned. Perhaps the cycle of construction and decline was not failure but fulfillment. Perhaps the jungle was always meant to return. These are philosophical questions, not scientific ones. But they hover over Maya studies like the mist that rises from the forest at dawn. We look at the ruins and see tragedy. The Maya may have seen completion. Let us return to the concrete. The pre-classic cities tell us that Maya civilization was far older and far more sophisticated than earlier scholars realized. The foundations were laid not in the classic period but centuries before in the swamps and jungles of the Mirador Basin. The architecture of these early cities shows sophisticated engineering. The massive pyramids were not solid piles of rubble. They had internal structures, drainage systems, and carefully planned approaches. The facades were covered with painted stucco, featuring elaborate iconographic programs that depicted gods, supernatural creatures, and cosmic themes. The stucco masks at El Mirador are particularly impressive. Some are 2 stories tall. They show the faces of deities, often with elaborate headdresses and symbolic elements. These were not simple decorations. They were statements about the nature of the cosmos and the place of the city within it. Creating these masks required artistic skill, but also organizational capacity. The stucco had to be mixed and applied while still wet. Teams of artists and labourers had to work in coordination. The designs had to be planned in advance. This was not folk art. This was institutional art produced by specialists working within an organised cultural framework. The same sophistication appears in the urban planning. The pre-classic cities were not random agglomerations. They had oriented plazas, standardized building types, and consistent relationships between structures. The central precincts were distinct from residential areas. Causeways connected major buildings. This level of planning implies central authority. Someone was making decisions about where buildings would go, how resources would be allocated, what the city would look like. That someone was almost certainly a king, or a group of elites functioning as a ruling class. The pre-classic Maya had all the elements of complex civilization: urbanism, monumental architecture, artistic sophistication, trade networks, social hierarchy, agricultural intensification. They lacked only one thing that later periods would provide: writing. Or did they? The earliest securely dated Maya inscriptions come from the 3rd century BCE, but there are tantalizing hints of earlier writing. Some researchers believe that the pre-classic Maya had a script that has not survived, or that has not yet been recognized. The standardization of iconography suggests a symbolic system that may have been ancestral to later hieroglyphic writing. The question matters because writing is often seen as a marker of full civilization. If the pre-classic Maya had writing, they were even more sophisticated than currently recognized. If they did not, then the development of Maya script becomes a phenomenon of the late pre-classic and classic periods, something that emerged after the first great cities were already built. Either way, the pre-classic Maya were remarkable. They created a civilization in one of the least hospitable environments on Earth. They built monuments that still inspire awe after 2,000 years, and they did it without metal, without wheels, without draft animals, and without any of the advantages that Old World civilizations enjoyed. How did they know what to build? How did they organize the labor? How did they develop the techniques? The conventional answer is that they figured it out. Human beings are intelligent and adaptable. Given enough time and population, complex societies emerge. The Maya had time and population. They had cultural traditions inherited from earlier peoples. They had trade connections that brought ideas and materials. They had everything they needed. The unconventional answer is that they had help. Not divine help in the religious sense, not supernatural intervention, something else. Something that provided knowledge or technology or guidance. Something that accelerated what should have been a slower process. We will explore that possibility in later chapters. We will look at the iconography that has fueled decades of speculation. We will examine the claims of ancient astronaut theorists and the responses of mainstream archaeologists. We will try to separate evidence from fantasy, but for now, let us acknowledge the mystery. The pre-classic Maya appeared, built cities that rivaled anything in the ancient world, and then vanished. Their successors in the classic period would build on their foundations but never fully match their scale. El Mirador remained the largest Maya site ever built. Something happened in those early centuries, something that created a civilization of extraordinary sophistication. Understanding what that something was may be the key to understanding the Maya as a whole. The jungle has spoken. It has revealed cities older than Rome. Now we must listen to what those cities are trying to tell us. In the next chapter, we turn from stone to sky. The Maya were not only builders, they were astronomers of the highest order. Their knowledge of celestial cycles was uncanny. Their calendar tracked time across millions of years. And their observations of the heavens raise questions that conventional science struggles to answer. The mathematics of the stars awaits. Chapter 3. The Mathematics of the Stars. The Dresden Codex sits in a climate-controlled vault in the Saxon State Library in Germany. It is a folding screen book made of fig bark paper, coated with lime plaster and covered with painted glyphs and images. It measures roughly 3.5 meters when fully extended. It dates to the 11th or 12th century CE, though it is almost certainly a copy of much older originals. It is one of only 4 Maya books to survive the Spanish conquest. The rest were burned. Diego de Landa, the Franciscan bishop of Yucatan, wrote in 1562 that he ordered the destruction of Maya books because they contained nothing but superstition and lies of the devil. In a single bonfire at Mani, he destroyed 27 hieroglyphic scrolls, 197 vessels, 5,000 idols, and an unknown number of other documents. We will never know what was lost, an entire civilization's written heritage reduced to ash in an afternoon. What survives, including the Dresden Codex, is a fragment of a fragment. But what a fragment! The Dresden Codex contains astronomical tables of stunning precision. It tracks the cycles of Venus across centuries. It predicts eclipses. It correlates multiple calendrical systems in ways that reveal a mathematical sophistication we're only beginning to appreciate. And it raises questions. Questions about how the Maya knew what they knew. Questions about where their astronomical knowledge came from. Questions that mainstream archaeology answers confidently, but that continue to trouble careful observers. Let us begin with what the Maya actually achieved. The Maya calendar is often discussed as if it were a single system. It was not. It was an interlocking set of cycles, each serving different purposes, all of them geared together like the wheels of a cosmic machine. The most basic cycle was the kin, the day. Days were the fundamental unit of Maya timekeeping. From days, everything else was built. The first major cycle was the Tzolk'in, a 260-day sacred calendar. The Tzolk'in combined 20 named days with 13 numbers, producing a cycle of 260 unique day names. This calendar was used for divination, for determining auspicious days, for ritual scheduling. It was not astronomical in the sense of tracking solar or lunar phenomena. It was cultural, embedded in Maya religion and daily life. The second major cycle was the Harb, a 365-day civil calendar. The Harb consisted of 18 months of 20 days each, plus a 5-day period at the end called Wyeb. The Harb approximated the solar year and was used for agricultural and administrative purposes. The Tzolk'in and Harb interlocked to create the calendar round, a cycle of approximately 52 years. Any combination of Tzolk'in and Harb dates would repeat after 18,980 days, or roughly 52 solar years. The calendar round was the basic framework for dating events in Maya life, but the Maya needed to track longer periods. For historical records, for astronomical calculations, for cosmological speculation, the calendar round was not enough. They needed a count that could extend indefinitely into the past and future. They created the long count. The long count was a cumulative count of days from a fixed starting point. That starting point in our calendar corresponds to August 11th, 3114 BCE. Why that date was chosen is uncertain. It may relate to mythological events, to astronomical cycles, or to calendrical calculations that we do not fully understand. The long count used a vigesimal system, base 20, with one modification. The basic units were kin, days, winal, 20 days, tun, 360 days, katun, 7,200 days, or roughly 20 years, and baktun, 144,000 days, or roughly 394 years. A typical long count date was written as 5 numbers separated by dots. For example, 9.15.10.0.0. This indicated 9 baktuns, 15 katuns, 10 tons, 0 winals, and 0 kin since the starting point. The date could be calculated precisely and compared with other dates across centuries. The long count allowed the Maya to think about time on scales that dwarf human history. The current cycle, the one that began in 3114 BCE, was scheduled to complete on December 21st, 2012 CE. This was the famous Maya apocalypse date that generated so much popular attention. The Maya did not actually predict apocalypse. They predicted the completion of a cycle and the beginning of a new one. Just as our calendar rolls over from December 31st to January 1st, Without the world ending, the Maya long count rolled over from 12.19. 19.17.19 to 13.0.0.0.0. A new Baktun began. Life continued. But the precision of the long count is impressive. The Maya were tracking time across more than 5,000 years with day-level accuracy. They were maintaining calendrical records that allowed comparison of events separated by centuries. They were thinking about time in ways that few ancient cultures matched, and they were doing more than just counting days. They were predicting astronomical events. The Dresden Codex contains a Venus table that tracks the synodic period of Venus across centuries. The synodic period is the time between successive appearances of Venus as the morning star as seen from Earth. The modern value is 583.92 days. The Maya calculated it as 584 days, an error of less than 2 hours over the entire cycle. This accuracy is remarkable. Venus is visible to the naked eye, but its movements are complex. It appears as the morning star for about 260 days, then disappears behind the sun, then reappears as the evening star for another 260 days, then disappears again before returning as the morning star. Tracking this cycle required patient observation over many years. The Maya did more than observe, they predicted. The Venus table in the Dresden Codex covers 365 Venus cycles, roughly 481 years. It includes correction factors to account for the small difference between 584 days and the true synodic period. The Maya understood that their idealized cycle drifted slightly from reality and built in mechanisms to compensate. Why did the Maya care so much about Venus? Venus was not just a point of light in the sky. Venus was Kukulkan, the feathered serpent, one of the most important deities in the Mesoamerican pantheon. The movements of Venus had religious and political significance. Wars were timed to Venus events. Kings claimed association with the planet. The appearance and disappearance of Venus was woven into Maya mythology. But there was also a practical dimension. If you can predict Venus, you can predict eclipses. The Dresden Codex contains an eclipse table that covers 33 years of lunar eclipses. The table identifies potential eclipse dates and provides correction factors for observational uncertainty. Eclipse prediction is difficult. It requires understanding the interplay of solar and lunar cycles, the nodes where the moon's orbit crosses the ecliptic, and the geometry of shadow and light. The Maya could not have developed these tables without sophisticated mathematical thinking, and that thinking was based on a number system more advanced than anything Europe had at the time. The Maya used a positional number system with base 20. Unlike Roman numerals, which are additive and awkward for calculation, Maya numerals allowed complex arithmetic. More importantly, the Maya had the concept of zero. Zero seems simple to us. It is the placeholder, the nothing, the empty set. But zero was not obvious to ancient mathematicians. The Greeks never fully developed it. The Romans did not have it. The concept of zero as a number in its own right, not just an absence, was one of humanity's great intellectual achievements. The Maya had zero by at least the 4th century BCE. They represented it with a shell glyph, an elegant symbol for emptiness. With zero, their positional system became fully functional. Numbers of any size could be written compactly and manipulated arithmetically. This mathematical sophistication enabled the astronomical calculations. Without positional notation, tracking Venus cycles over centuries would have been impossibly cumbersome. With it, the Maya could build tables, identify patterns, and make predictions that would hold for generations. Where did this knowledge come from? The conventional answer is that it developed internally. The Maya inherited some mathematical and astronomical traditions from earlier Mesoamerican cultures, particularly the Olmec. They refined and extended these traditions over centuries of observation and calculation. The precision we see in the Dresden Codex is the result of generations of skywatchers, patiently recording, comparing, and correcting. This explanation is plausible. Human beings are capable of remarkable intellectual achievements when motivated. The Maya had motivation. Their religion demanded astronomical knowledge. Their politics incorporated celestial events. Their agriculture depended on seasonal cycles. They had every reason to develop sophisticated astronomy, but there are puzzles. The speed of development again is striking. The Maya seem to have jumped from simple skywatching to precision astronomy in a relatively short time. Where are the intermediate stages? Where are the tables with larger errors? The systems that did not quite work? The trial and error that should precede mastery? The connection between observation and calculation is mysterious. Naked eye observation can tell you when Venus rises and sets, but calculating the synodic period to 5 decimal places requires more than observation. It requires mathematics. Where did the Maya learn to do that kind of calculation? The correlation with other knowledge systems is intriguing. Maya astronomy was not isolated. It was connected to architecture, to writing, to ritual, to everything. The integration is so complete that it appears almost designed, as if someone laid out a master plan and the Maya implemented it. These are not proofs of outside influence. They are observations that invite explanation. Conventional archaeology explains them in conventional ways. Alternative researchers see them as clues pointing towards something else. Let us consider one specific claim. The Temple of Kukulkan at Chichen Itza, known as El Castillo, is one of the most famous Maya structures. It is a stepped pyramid roughly 75 feet tall, with staircases on all 4 sides leading to a temple at the summit. Each staircase has 91 steps. 4 staircases times 91 steps equals 364. Add the platform at the top and you get 365, the number of days in the solar year. The pyramid is astronomically aligned. During the spring and fall equinoxes, the afternoon sun casts a shadow on the northwest balustrade that creates the illusion of a serpent descending the staircase. The serpent's head, carved in stone at the base of the stairs, seems to come alive as the shadow joins it. Thousands of tourists gather each equinox to watch this effect. Is this intentional? Was El Castillo designed to produce this phenomenon? Most archaeologists believe yes. The alignment is too precise to be accidental. The Maya knew what they were doing. They built a calendar in stone, a temple, that marked the turning points of the year with light and shadow. The question is how? How did the Maya calculate the angles? How did they know where to place the building? How to orient the stairs? How to carve the serpent head so that the shadow would align precisely? Modern architects with computers and surveying equipment would find this challenging. The Maya did it with observation, geometry, and trial and error. Or so the conventional explanation goes. Alternative researchers ask whether trial and error is really sufficient. Building a pyramid takes years or decades. You cannot try different alignments and see which works. You have to get it right the first time. That requires knowledge, not experimentation. Where did that knowledge come from? Some researchers point to the consistency across Maya sites. Astronomical alignments appear not just at Chichen Itza, but at Uxmal, Palenque, Copan, and dozens of other cities. The orientations vary, tracking different celestial events, but the precision is similar. This suggests a shared body of knowledge, a tradition that was transmitted from generation to generation. That tradition must have originated somewhere. The Maya did not invent astronomy independently in each city. They learned it from someone or something. The question is who or what. The conventional answer is cultural transmission. Earlier Mesoamerican cultures, particularly the Olmec, developed astronomical practices that the Maya inherited and extended. The knowledge spread through trade, migration, and cultural contact. No outside influence is required. The alternative answer is that the Maya received their astronomical knowledge from a non-human source. Ancient astronauts, extraterrestrial visitors, a lost advanced civilization. Someone who possessed knowledge that should not have existed at that time and place. This is an extraordinary claim. It requires extraordinary evidence. Does such evidence exist? The ancient astronaut theorists point to several sources. Maya mythology describes gods who came from the sky. The Popol Vuh, the Quiche Maya creation myth, tells of beings who created humanity and taught them the arts of civilization. Could these myths preserve memories of actual contact with advanced beings? Maya iconography includes images that seem anomalous. The sarcophagus lid of Pakal the Great at Palenque shows a figure surrounded by complex machinery or technology. To some observers, Pakal appears to be operating a spacecraft. We will examine this claim in detail in the next chapter. Maya astronomical knowledge is more precise than seems possible for naked eye observation. The Dresden Codex calculations imply mathematical sophistication that exceeds what we would expect from a Stone Age culture. Could this knowledge have been given rather than discovered? These arguments are not conclusive. Mainstream archaeology rejects them firmly. The myths are metaphorical, not historical. The iconography follows. Maya artistic conventions, not depictions of technology. The astronomical precision is explained by patient observation over centuries. Both sides have points. Neither has definitive proof. What we can say with confidence is that Maya astronomy was extraordinary. The precision of their calculations, the sophistication of their calendar, the integration of celestial observation into every aspect of their culture, all of this sets them apart from most ancient civilizations. The Maya were watching the stars. They were counting the days. They were tracking Venus and predicting eclipses. They were building pyramids aligned to equinoxes and solstices. They were doing things that required knowledge, coordination, and purpose. Whether that knowledge came from within or from beyond, the achievement stands. The Maya understood the cosmos in ways that we are only beginning to recover. The Dresden Codex is a survivor. One book out of thousands, one fragment of a shattered tradition. What it preserves is precious. What was lost, we can only imagine. The Spanish burned the books. They believed they were destroying superstition and devil worship. They were destroying a library, a body of knowledge accumulated over centuries, calculations that track the heavens across millennia. We will never fully know what the Maya knew. We have pieces, we have hints, we have ruins and carvings and a handful of surviving texts, but the stars are still there. The cycles still turn. The long count has rolled over into a new Baktun. Time continues as the Maya understood it would. In the next chapter, we descend from the sky to the earth. We enter a tomb, the tomb of a king whose sarcophagus lid has sparked decades of controversy. The tomb of Pakal the Great at Palenque. Is it a portrait of a Maya ruler in the underworld, or is it something else entirely? The astronaut question awaits. Chapter 4. Pakal and the astronaut question. June 15th, 1952. The Mexican archaeologist Alberto Rusluilier stands at the base of a hidden stairway inside the Temple of the Inscriptions at Palenque. For 4 years, his team has been excavating this passage, removing rubble fill that the ancient Maya deliberately placed to seal what lies below. The stairway descends roughly 80 feet into the pyramid's core. At the bottom, a triangular doorway opens into a vaulted chamber. Ruz enters. The air is heavy, ancient, undisturbed for over 1,000 years. What he sees takes his breath away. The chamber is roughly 30 feet long and 13 feet wide. The walls are decorated with stucco reliefs showing 9 figures, probably lords of the underworld. But the centerpiece is a massive stone sarcophagus, roughly 12 feet long and 7 feet wide, covered by an elaborately carved lid weighing several tons. Ruz has found the tomb of Pakal the Great, one of the most powerful kings in Maya history. Kinich Janab Pakal ruled Palenque from 615 to 683 CE, a reign of 68 years. Under his leadership, Palenque became one of the most important cities in the Maya world. The Temple of the Inscriptions, built as his funerary monument, contains one of the longest hieroglyphic texts known from ancient Mesoamerica. Pakal was buried with jade ornaments, a jade mosaic mask covering his face, and offerings of obsidian, shell, and pottery. His skeleton showed he lived to an advanced age, perhaps 80 years old, with significant arthritis and dental wear consistent with the strains of a long life. But it is not the burial that has captured the world's imagination. It is the sarcophagus lid. The lid is a single slab of limestone, roughly 12 feet by 7 feet, carved with an intricate scene. At the center is a human figure, reclining, surrounded by complex imagery. Above him rises what appears to be a cross or tree. Below him opens a skeletal jaw, perhaps representing the entrance to the underworld. Around the edges are astronomical symbols and hieroglyphic texts. The conventional interpretation is clear. The figure is Pakal, shown at the moment of death, descending into Xibalba, the Maya underworld. The tree above him is the world tree, the axis mundi that connects the realms of the living and the dead. The skeletal jaw below is the earth monster, swallowing the king as he passes from life to death. The imagery is consistent with Maya cosmology as we understand it from other sources. The world tree appears throughout Maya art. The underworld journey is a central theme of Maya religion. The sarcophagus lid is a statement about Pakal's death and his expected transformation into a divine ancestor. This interpretation is well supported by expert epigraphers and iconographers. The hieroglyphic texts on the lid and in the temple confirm that the image relates to death and descent. The symbolism matches patterns seen at other Maya sites, but there is another interpretation, one that has captivated millions of people and fueled decades of controversy. In 1968, the Swiss author Erich von Daniken published Chariots of the Gods, a book that would sell over 70 million copies and launch the ancient astronaut movement. Von Daniken's central claim was that extraterrestrial beings visited Earth in antiquity and influenced human civilizations. His evidence included various ancient monuments and artworks that he interpreted as depicting alien technology. The sarcophagus lid of Pakal was one of his star exhibits. Von Daniken looked at the image and saw something very different from Maya scholars. He saw a man operating a machine. The reclining figure, he argued, was sitting in a seat, hands manipulating controls, feet pressing pedals. The frame around him was the body of a spacecraft. Flames or exhaust emerged from the bottom. The figure was not dying, he was piloting. The interpretation was vivid, intuitive, and wildly popular. To modern eyes trained to recognize technology, the image does look like a person in a vehicle. The posture, the arrangement of elements, the sense of enclosure, all of it can suggest a cockpit. The idea spread rapidly. The astronaut interpretation appeared in documentaries, books, and eventually on the History Channel's Ancient Aliens program. Millions of people who have never read a Maya inscription believe that Pakal was an ancient astronaut, or at least that the Maya depicted space travel on his tomb. What should we make of this? Let us start with what we know for certain. The sarcophagus lid is a real artifact. It exists. It depicts something. The question is, what? Professional Mayanists reject the astronaut interpretation completely. Their objections are specific and detailed. First, the elements that von Daniken identified as technology are recognizable Maya symbols. The frame around the figure is not a spacecraft. It is the world tree, adorned with serpent heads, quetzal birds, and other standard Maya motifs. These elements appear throughout Maya art. They are not unique to Pakal's tomb. Second, the posture of the figure is consistent with Maya artistic conventions for depicting the dead or dying. The reclining position, the arrangement of limbs, the relationship to the underworld below, all of this follows patterns seen in other Maya monuments. Pakal is not operating controls, he is falling into death. Third, the hieroglyphic texts tell us explicitly what the image means. The inscriptions describe Pakal's death, his descent into the underworld, and his expected rebirth as a god. There is no mention of vehicles, space travel, or technology of any kind. Fourth, the skeletal jaw below the figure is clearly the earth monster, a standard Maya symbol for the entrance to the underworld. The flames that von Daniken interpreted as rocket exhaust are stylized bones and death symbols. Fifth, the cross above the figure is the world tree with a celestial bird perched at its top. The world tree is one of the most important symbols in Maya cosmology. It appears on countless monuments and in the surviving Maya codices. The Mayanist interpretation is not speculation. It is based on decades of research, the decipherment of Maya hieroglyphics, the comparison of thousands of images across hundreds of sites, and a deep understanding of Maya religion and symbolism. From this perspective, the astronaut interpretation is not just wrong, it is embarrassingly wrong. It results from looking at Maya art with modern eyes and projecting modern meanings onto ancient symbols. Von Daniken and his followers counter that mainstream scholars are too closed-minded to consider alternative interpretations. They argue that the resemblance to a spacecraft is too striking to be coincidental. They suggest that the Maya may have depicted something they actually witnessed, something that conventional archaeology cannot explain. Who is right? The honest answer is that we cannot know with absolute certainty what was in the minds of the Maya artists who carved Pakal the sarcophagus lid. We can only work from evidence, and the evidence strongly supports the conventional interpretation. Every element of the image can be explained by reference to Maya symbolism. The interpretation is consistent with everything else we know about Maya religion. The hieroglyphic texts confirm the meaning. There is no need to invoke spacecraft or extraterrestrial visitors, but let us be fair to the alternative perspective. The astronaut interpretation is wrong, but it is not crazy. The image does have a technological appearance to modern eyes. If you have never studied Maya iconography, if you do not know what the world tree means, if you are unfamiliar with Maya conventions for depicting death and descent, the astronaut interpretation is understandable. The problem is that familiarity resolves the mystery. Once you learn Maya symbolism, the astronaut disappears. What seemed like technology reveals itself as religion. What seemed like a spacecraft is clearly a cosmic diagram. This is a recurring pattern in ancient astronaut claims. Unfamiliar imagery is interpreted as technology. Expertise dissolves the interpretation. The mystery was never in the artifact, it was in the observer's ignorance. Does this mean we should dismiss all ancient astronaut claims? Not necessarily. We should evaluate each claim on its evidence. We should be skeptical of interpretations that ignore expert knowledge. But we should also remain open to genuine mysteries. The question is whether there are genuine mysteries in Maya culture that conventional archaeology cannot explain. The sarcophagus lid is not one of them, but there may be others. Let us consider what we do not know about the Maya. We do not know why they chose the specific date of their long count starting point. August 11th, 3114 BCE corresponds to no known astronomical or historical event. Why that date? What happened, in Maya understanding, at the beginning of the current cosmic cycle? We do not know the full extent of Maya astronomical knowledge. The Dresden Codex preserves some calculations, but the Spanish destroyed the rest. What else did the Maya know? What observations and predictions have we lost forever? We do not know the origins of some Maya technologies. Maya blue, the brilliant pigment used in murals and on sacrificial victims, was not fully understood until modern chemists analysed it. The Maya created a nanostructured material, indigo bonded to palygorskite clay, that remained stable for centuries. How did they discover this? Trial and error seems inadequate for such a sophisticated result. We do not know the full meaning of Maya mythology. The Popol Vuh describes creation, destruction, and the activities of gods and heroes. How much of this is metaphor? How much is history? How much might encode real events that we cannot currently recognize? These are legitimate mysteries. They do not require ancient astronauts to explain them, but they do suggest that our understanding of Maya civilization is incomplete. There may be surprises yet to come. The fascination with ancient astronauts reflects something deeper than gullibility. It reflects a sense that the ancient world was more sophisticated than we often assume. It reflects a desire to connect human history to a larger cosmic story. It reflects dissatisfaction with explanations that seem to diminish the achievements of ancient peoples. The irony is that ancient astronaut theories actually diminish those achievements. By attributing Maya accomplishments to extraterrestrial help, the theories deny the Maya credit for what they genuinely accomplished. The Maya did not need aliens to build pyramids, develop astronomy, or create their calendar. They did it themselves. That is the true wonder. Pakal was not an astronaut. He was a king, a human being who ruled for 68 years, built monumental architecture, commissioned beautiful art, and died like all mortals die. His sarcophagus lid depicts his journey into death, not his departure in a spacecraft. The image is still remarkable. It is still beautiful. It still tells us something profound about how the Maya understood existence. Death was not an ending. It was a transformation. The king who descended into the underworld would rise again as a god. The world tree connected all realms. Time cycled eternally. That cosmology is worth understanding on its own terms. It does not need aliens to make it interesting. It does not need technology to make it meaningful. It is a human creation, made by human beings who thought deeply about life, death, and the structure of the cosmos. The astronaut interpretation will not go away. It is too visually compelling, too emotionally resonant, too embedded in popular culture. But it is wrong, and we should be clear about that even as we acknowledge the genuine mysteries that remain. Pakal sleeps beneath his pyramid. His jade mask stares into eternity. The world tree rises above him. The underworld opens below. He made the journey that all Maya kings expected to make. He became what the inscription said he would become. Not an astronaut, an ancestor, a god. The real mystery is not whether Pakal flew a spacecraft. The real mystery is how a civilization in the jungle, without metal tools or draft animals, created a culture of such sophistication and beauty. The Maya achieved extraordinary things. We should honor those achievements by trying to understand them accurately. The astronaut hypothesis is a distraction. The truth is more interesting. In the next chapter, we examine the calendar in detail. Not the simplified version that appeared in 2012 apocalypse movies. The real calendar, the system of interlocking cycles that tracked time across millions of years. The calendar that counts forever. What did the Maya know about time, and what were they trying to tell us? Chapter 5. The calendar that counts forever. December 21st, 2012. The world did not end. For years, popular culture had been building toward this date. Books, movies, websites, and television programs warned of impending catastrophe. The Maya calendar, they claimed, predicted the end of time on this precise day. Doomsday scenarios range from asteroid impacts to magnetic pole reversals to the arrival of a mysterious planet called Nibiru. None of it happened. The sun rose, the day passed, life continued. The 2012 phenomenon was a spectacular misunderstanding. It took a sophisticated ancient calendar system, stripped it of context, and projected modern apocalyptic anxieties onto it. The Maya never predicted the end of the world. They predicted the end of a cycle. There is a difference. To understand what the Maya actually believed about time, we need to set aside the pop culture noise and examine their calendar on its own terms. What we find is not prophecy of doom. It is something far more interesting. A conception of time so complex, so layered, so mathematically rigorous, that it challenges our own assumptions about past and future. The Maya did not use a single calendar. They used multiple calendars running simultaneously, each serving different purposes, all of them interlocked through mathematical relationships. We have already mentioned the Tzolk'in and the Hab. The Tzolk'in, the 260-day sacred calendar, governed ritual life. The Hab, the 365-day civil calendar, tracked the agricultural year. Together they formed the calendar round, a cycle of roughly 52 years. But the calendar round was not sufficient for Maya needs. 52 years is a human lifetime. For historical records, for astronomical calculations, for cosmological speculation, the Maya needed a system that could extend indefinitely. Enter the long count was the linear count of days from a fixed starting point. Unlike the cyclical Tzolk'in and Hab, the long count ran continuously, accumulating days without resetting. It was the backbone of Maya historical chronology. The starting point, known as the creation date, corresponds in our calendar to August 11th, 3114 BCE. This date marked the beginning of the current world age, the fourth creation in Maya mythology. 3 previous creations had existed and ended. The current creation would also end, at which point a new cycle would begin. The long count used a modified base 20 system with 5 positions, from smallest to largest. Kin, 1 day, Winal, 20 days, Tun, 360 days, Katun, 7,200 days, about 20 years, and Baktun, 144,000 days, about 394 years. A typical long count date was written as 5 numbers, 9.16.4.10.8 for example, meant 9 Baktuns, 16 Katuns, 4 Tuns, 10 Winals, and 8 Kin had elapsed since the creation date. The cycle that ended on December 21st, 2012 was the 13th Baktun. 13 Baktuns equal 1 Piktun in the extended count. When the long count reached 13.0.0.0.0, the Baktun counter reset and a new great cycle began. This was not an ending, it was a rollover, like an odometer reaching 99,999 and flipping to 100,000. The world did not end when the Maya Baktun count reset. It simply started counting the next cycle. Maya inscriptions explicitly reference dates far beyond the current cycle. The Temple of the Inscriptions at Palenque records events projected millions of years into the future. The Maya conceived of time extending indefinitely in both directions. The 2012 date was significant but not terminal. So where did the apocalypse idea come from? The answer is a mix of genuine Maya beliefs, colonial era distortions, and modern projection. The Maya did believe in world ages. The Popol Vuh, the Quiche Maya creation narrative recorded after the Spanish conquest, describes 3 failed creations before the current one. The first humans were made of mud and dissolved. The second were made of wood and were destroyed by a great flood. The third were transformed into monkeys. Only the fourth creation, made from maize dough, succeeded. This cyclical view of creation and destruction echoed across Mesoamerica. The Aztecs had a similar concept of 5 suns or world ages. Each age ended in catastrophe. The current age would also end eventually. But end does not mean annihilation. In Maya thought, the end of an age was also the beginning of a new one. Death and rebirth, destruction and creation. The cycle continues. Colonial era interpreters, primarily Spanish friars, filtered Maya beliefs through Christian apocalypticism. The Book of Revelation cast a long shadow. European culture was steeped in end times thinking. When the friars recorded Maya beliefs, they emphasized elements that fit their own framework. Cyclic renewal became linear apocalypse. Modern interpreters added another layer. New Age authors, starting in the 1970s and 80s, seized on the 2012 date as evidence of Maya prophecy. José Argüelles, author of The Mayan Factor, linked the long count to galactic alignments and spiritual transformation. Terence McKenna's time wave zero theory, though not originally connected to the Maya, was eventually synchronized with the 2012 date. The result was a cultural phenomenon that had little to do with actual Maya beliefs. The ancient Maya would not have recognized the apocalyptic scenarios promoted in their name. What did the Maya actually think about the end of the Bactun cycle? The honest answer is that we do not fully know. The Spanish destroyed most Maya books. The surviving sources, primarily the Popol Vuh and the books of Chilam Balam, were recorded after the conquest and show clear colonial influence. We cannot be certain how much they preserve authentic pre-Columbian belief. What we can say is that the Maya treated calendrical transitions as significant. The end of a Katun, roughly every 20 years, was marked with monuments and rituals. The end of a Bactun, roughly every 400 years, was even more important. These transitions were times of cosmic renewal, moments when the world was symbolically recreated. The 2012 date, the end of the 13th Bactun, was undoubtedly significant in Maya thought. 13 was a sacred number. The 13th Bactun was the last in the current cycle before the Pictun counter would increment. This was a major transition. But transition is not apocalypse. The Maya expected the world to continue. They expected the next cycle to begin. They expected time to keep counting. The calendar itself makes this clear. The long count has higher orders beyond the Bactun. The Pictun, the Kalabtun, the Kinchiltun, the Alautun. These units extend the count to periods of millions and billions of years. Why create such units if you expected time to end? The Maya were not predicting doom. They were building a calendar capable of tracking deep time, a calendar that could count forever. This raises a question. Why did the Maya need such a calendar? What purpose did it serve? Part of the answer is astronomical. Maya astronomy tracked cycles of Venus, Mars, and the Moon that spanned centuries. The long count provided a framework for recording and predicting these cycles. Without a continuous day count, astronomers could not correlate observations separated by hundreds of years. Part of the answer is historical. Maya kings claimed legitimacy through ancestry and precedent. Inscriptions traced royal lineages back generations. The long count allowed precise dating of historical events, connecting current rulers to ancient predecessors. History became a tool of political power. Part of the answer is religious. Maya cosmology was deeply concerned with time. The gods created and destroyed worlds according to cyclic patterns. Rituals had to be performed on correct dates. The calendar was not just a record-keeping device. It was a sacred technology, aligning human action with cosmic rhythm. But there may be more. The precision of Maya timekeeping, the extension of the count into millions of years, suggest concerns that go beyond immediate practical needs. The Maya were thinking about time in ways that anticipate modern cosmology. Consider the creation date. August 11th, 3114 BCE. This date is not arbitrary. It was calculated by working backwards from observed astronomical cycles. The Maya understood that time extended before the current world age. They set their 0 point at a moment of cosmic significance, not historical convenience. Consider the extended counts. The Alautun, the largest known Maya time unit, spans roughly 63 million years. This is deep time by any standard. The Maya were conceptualizing durations that dwarf human history, that approach geological and even cosmological scales. Why? What were they tracking? What did they expect to find in cycles lasting millions of years? Conventional archaeology does not fully answer this question. The practical uses of the calendar are clear. The deep time extensions seem excessive. Why count to 63 million years if you only need a few centuries? One possibility is astronomical. There may be long period cycles that the Maya observed or calculated. The precession of the equinoxes, for example, takes roughly 26,000 years. The alignment of planets might create cycles spanning millennia. If the Maya were tracking such phenomena, they would need a calendar capable of recording them. Another possibility is mythological. Maya creation stories describe multiple world ages. If each age lasted millions of years, the calendar would need to count that far. The extended units may relate to cosmological concepts that we do not fully understand. A third possibility is that the Maya valued precision for its own sake. Perhaps they extended their calendar not because they needed to track long periods, but because they could. The mathematical elegance of a complete vigesimal system, capable of counting any number of days, may have been its own reward. Or perhaps there is something we are missing. Something that the destroyed codices would have explained. Something that the Spanish fires consumed forever. The calendar remains, the books are gone. We have fragments of a system that was once complete. We can see the mathematics, the astronomical correlations, the ritual applications, but the meaning, the purpose, the world view that gave rise to it, that we can only partially reconstruct. The Maya counted time. They counted it with extraordinary precision across extraordinary spans. They believed that time was cyclical, that worlds ended and began, that the present was one phase of an eternal rhythm. December 21st, 2012 was a significant date in that rhythm. Not an apocalypse, not an ending, a transition. A moment when one great cycle closed and another opened. The Maya would not have panicked. They would have celebrated. They would have performed rituals to ensure a favourable transition. They would have looked forward to the new age, whatever it might bring. The calendar counts forever. Time does not stop. The cycles continue. We are now more than a decade into the new Baktun. The world continues. The stars still turn. The Maya calendar still runs, even if few people mark its passages. What the Maya knew about time, we're only beginning to appreciate. Their calendar was more than a tool. It was a philosophy. It was a cosmology. It was a way of understanding humanity's place in an eternal cyclical cosmos. The books are burned. The cities are ruins. The jungle has reclaimed its own. But the calendar survives. Carved in stone, painted on pottery, encoded in the movements of planets, the Maya gave us something precious, a different way of thinking about time, not the linear arrow of Western progress, always moving forward, always leaving the past behind, but a spiral, returning to familiar points at higher levels, cycling through creation and destruction, forever. In the next chapter, we examine what the Maya did with their time, the rituals that mark their days, the blood that sanctified their monuments, the connection between sky and sacrifice, blood and sky. The calendar was not abstract, it demanded action, and those actions were written in stone and flesh. Chapter 6. Blood and Sky. The priest stands atop the pyramid. Below him, the city spreads toward the jungle edge. Thousands have gathered in the plaza, their faces turned upward, waiting. The sun climbs toward its zenith. Venus hangs in the morning sky, bright and unwavering. The timing is precise. Astronomers have calculated this moment for months, perhaps years. The calendar has been consulted. The auguries have been read. Everything aligns. Today is the day. The captive is brought forward. He is a noble, taken in a flower war designed specifically to capture rather than kill. His body is painted blue, the colour of sacrifice, the colour of water and sky and the realm between worlds. He does not struggle. He knows his role. In Maya cosmology, sacrifice is not murder. It is transformation. It is passage. It is the feeding of the gods who sustain creation. The obsidian blade catches the light. What happens next is swift and brutal by modern standards. The chest is opened. The heart is removed while still beating. It is offered to the sky, to the sun, to the forces that keep the cosmos in motion. Blood flows down the pyramid steps. Blood, the most precious substance in Maya thought. Blood, the food of the gods. Blood, the currency that pays for continued existence. This is the Maya civilization that popular culture often ignores. Not the peaceful astronomers, not the wise calendar makers, the Maya who believed that the universe required blood to continue, the Maya who built their greatest monuments as stages for ritual killing, the Maya who understood the cosmos as a hungry machine that would consume itself without constant feeding. The connection between astronomy and sacrifice was not coincidental, it was essential. The Maya did not study the stars out of curiosity. They studied them to know when the gods needed to be fed. The calendar was not a neutral record of passing days. It was a schedule of obligations. Certain days demanded blood. Certain alignments required death. Venus was particularly important. The Maya tracked Venus with obsessive precision, and that precision had deadly purpose. The heliacal rising of Venus, its first appearance as the morning star after a period of invisibility, was considered a moment of cosmic danger. The planet was associated with warfare and destruction. Its emergence required blood to be appeased. The Dresden Codex, that precious surviving manuscript, contains tables that predict Venus appearances centuries in advance. These were not academic exercises. They were practical guides for military and ritual planners. Wars were timed to Venus events. Sacrifices were scheduled to planetary alignments. The heavens dictated the calendar of death. This integration of astronomy and violence disturbs modern sensibilities. We want to admire Maya intellectual achievements without confronting how those achievements were used. We want the calendar without the blood. But they cannot be separated. The Maya understood them as one system. To grasp this, we need to understand Maya cosmology at a deeper level. The Maya did not see the universe as a stable, self-sustaining system. They saw it as fragile, constantly threatening to collapse into chaos. The gods had created the current world, but creation was not a one-time event. It was an ongoing process that required continuous input. That input was blood. Blood carried Chulel, the sole force that animated all living things. When blood was shed in sacrifice, Chulel was released and transferred to the supernatural realm. The gods received nourishment. The cosmic machinery continued to turn. The sun rose, the rain fell, the maize grew. Without sacrifice, the system would fail. The sun would stop, the rains would cease. The world would end as previous worlds had ended. Sacrifice was not optional, it was the price of existence. This belief was not unique to the Maya. Similar ideas appear throughout Mesoamerica. The Aztecs, who came later, are famous for their massive human sacrifices, but the Maya preceded them and shared the fundamental logic. Blood feeds the gods sustain the world. Gods, therefore blood must flow. The scale of Maya sacrifice is debated. Early scholars, influenced by Spanish colonial accounts, may have exaggerated. Recent archaeology suggests that mass sacrifice was less common among the Maya than among the Aztecs. But it definitely occurred. The evidence is undeniable. Cenotes, the natural sinkholes that provided water in the limestone landscape of Yucatan, were particularly important sacrificial sites. The sacred cenote at Chichen Itza has yielded hundreds of human remains, along with jade, gold, and other offerings. Victims were thrown into the water as gifts to Chak, the rain god. The cenote was a portal to the underworld, and the sacrifices were messengers sent to the gods. Skeletal analysis reveals who was sacrificed. Children appear frequently, young adults, captives taken in war, occasionally members of the elite. The victims were not random. They were chosen according to criteria we only partially understand. Youth may have been valued for its purity. Captive warriors carried the prestige of defeated enemies. Elite victims demonstrated ultimate devotion. The methods varied. Heart extraction was the most dramatic, but not the only form. Decapitation was common, especially for ballgame losers, drowning in cenotes, burning, arrow sacrifice, in which the victim was tied to a frame and shot by multiple archers. Each method had symbolic meaning. Each was appropriate for particular contexts. Bloodletting, a milder form of sacrifice, was practiced by the elite themselves. Kings and queens pierced their tongues, earlobes, and genitals with obsidian blades and stingray spines. The blood was collected on paper and burned, sending the essence to the gods. Visions induced by blood loss and pain were interpreted as divine communication. The famous lintels of Yaxchilan depict Lady Cabal Suk, a royal woman, pulling a thorn-studded rope through her tongue. Blood drips onto paper in a bowl at her feet. From the blood and smoke rises a vision serpent, a conduit to the supernatural. Her husband, the king-shield jaguar, stands ready with a torch. This was not torture, it was devotion. It was the responsibility of rulers to feed the gods with their own blood. The ball game, that mysterious Mesoamerican sport played with a rubber ball in eye-shaped courts, was intimately connected to sacrifice. The game had multiple meanings. It reenacted mythological events. It resolved disputes between cities. It provided entertainment. But it also provided victims. Losing teams, or perhaps winning teams in some versions, faced sacrifice. The bull court was a threshold between worlds, and the game was a ritual drama whose ending was written in blood. The Great Ball Court at Chichen Itza, the largest in Mesoamerica, features carved panels showing decapitation. Players and spectators knew what was at stake. The integration of sport, religion, and death seems bizarre to modern observers. We separate these categories carefully. Games are entertainment. Religion is spiritual. Death is medical. The Maya collapsed these distinctions. The game was the religion. The religion was death. Death was entertainment. All of it was cosmic maintenance. The pyramids themselves were stages for sacrifice. Their height placed the rituals closer to the sky, closer to the gods. The steep stairs forced victims to climb toward their deaths, a physical enactment of the journey from earth to heaven. The blood that flowed down the steps sanctified the stone, charging it with sacred power. Temple summits were visible from across the city. The entire population could witness the moment of sacrifice, even if they could not see the details. The spectacle was public and communal. Everyone participated. Everyone shared responsibility for feeding the gods. This was not sadism. The Maya were not gratuitously cruel. They believed they were doing what was necessary. They believed the alternative was cosmic collapse. In their worldview, the priest wielding the obsidian blade was not a murderer. He was a maintainer. He was keeping the universe alive. Modern observers struggle with this. We want to admire the Maya. We want to celebrate their achievements. We do not want to think about the blood. But the blood was inseparable from the achievements. The same astronomical knowledge that impresses us was used to schedule killings. The same mathematical sophistication that we praise calculated the most auspicious days for death. This is not a condemnation, it is an attempt at understanding. Every civilization has aspects that later generations find abhorrent. The Greeks kept slaves. The Romans staged gladiatorial games. Medieval Europeans burned heretics. The Maya sacrificed humans. These practices made sense within their cultural frameworks, even as they horrify us today. The question is whether we can appreciate Maya achievements while acknowledging Maya practices. The answer must be yes. We can admire the astronomy without endorsing the sacrifice. We can study the calendar without celebrating the blood. We can recognize genius while not excusing violence. But we should not pretend the violence did not exist. Sanitizing the Maya does them no favors. It reduces them to a fantasy, a New Age projection of peaceful wisdom that never existed. The real Maya were complex. They were brilliant and brutal. They were human. The blood and the sky were one system. The Maya looked up and saw gods that needed feeding. They looked down and saw victims that could provide that feeding. The connection was logical, given their premises. The premises were different from ours, but the logic was sound. We may never fully understand why the Maya believed what they believed. The origins of Mesoamerican sacrifice are lost in prehistory. By the time we have records, the practice is already ancient and established. The Maya inherited it, elaborated it, and continued it for centuries. When the Spanish arrived, they were horrified by what they found. The conquistadors had their own forms of violence, including the Inquisition, but they could not comprehend sacrifice as religion. They destroyed what they could. They burned the books. They toppled the idols. They imposed Christianity at sword point. The sacrifices ended. The cenotes stopped receiving their offerings. The pyramids fell silent. The old gods were forgotten, or driven underground, or merged with Catholic saints in the syncretic religions that survive today. But the memory lingers. The cenotes still hold their secrets. The carvings still show the blood. The understanding of what the Maya believed and practiced is part of understanding who they were. The sky demanded blood. The Maya provided it. For centuries the system worked. The sun rose, the rain fell, the maize grew, the cities flourished. Then something changed. The cities were abandoned. The jungle returned. The sacrifices, whatever their cosmic purpose, did not prevent the collapse. In the next chapter, we examine that collapse. The mystery of the 9th century, the emptying of the lowlands, the end of classic Maya civilization. What happened? Why did the system fail? And was it really a collapse at all? The collapse that never was. Chapter 7. The collapse that never was. The last long count date inscribed at the great city of Tikal corresponds to August 16th, 869 CE. After that date, silence. No more monuments, no more records of kings and conquests, no more dates carved in stone. Across the Maya lowlands, the same pattern repeats. City after city falls silent during the 9th century. Palenque, Copan, Calakmul, Karakol. The great centres that had flourished for 500 years stop building, stop carving, stop recording. Within a few generations they are empty. Within a few centuries they are ruins swallowed by jungle. This is the Maya collapse. One of the great mysteries of archaeology. A civilization that rivaled any on Earth seemingly vanished within a century. Millions of people disappeared from the historical record. Cities that had stood for half a millennium were abandoned to the forest. What happened? Where did everyone go? And why? For decades, the collapse has fascinated researchers and the public alike. Theories abound: drought, warfare, environmental degradation, disease, social revolution. Each theory has evidence. None is fully satisfying. The collapse remains one of archaeology's great unsolved puzzles. But here is a secret that popular accounts often miss. The Maya did not collapse. Not really. Not in the way the word implies. The lowland cities were abandoned. That is true. The classic period political system disintegrated. That is also true. But the Maya people did not vanish. They did not die out. They did not forget who they were. They simply changed. Today, there are approximately 7 million Maya living in Guatemala, Mexico, Belize, and Honduras. They speak 30 different Maya languages. They maintain traditions that stretch back millennia. They are the descendants of the people who built Tikal and Palenque and Chichen Itza. The Maya civilization did not collapse. It transformed. This distinction matters. When we speak of collapse, we imagine catastrophe, mass death, complete disappearance. The historical reality is more nuanced. The political system failed, the cities emptied, but the people survived. They moved, they adapted, they continued. Understanding this reframes the mystery. We are not asking why the Maya died. We are asking why they left their cities. We are asking why a particular form of civilization ended. We are asking what drove millions of people to abandon centuries of urban life and disperse into the countryside and highlands. Let us examine the evidence. The abandonment of the lowland cities was not simultaneous. It was a rolling collapse that unfolded over roughly a century. Different cities fell at different times, some in the early 9th century, some in the late 9th century. A few, like Chichen Itza, continued into the 10th century before succumbing. The sequence suggests contagion. Not literal disease necessarily, but cascading failure. When one city fell, its neighbours lost trade partners, military allies, economic connections. Their own systems became stressed. They fell too, and their fall stressed still more neighbours. Collapse bred collapse. But what triggered the initial failures? What pushed the first dominoes? The leading candidate is drought. Paleoclimate studies based on sediment cores, stalagmites, and other proxies reveal that the 9th century was one of the driest periods in Maya history. Multiple severe droughts occurred, some lasting years. In a region dependent on rainfall for agriculture and drinking water, extended drought would have been catastrophic. The Maya lowlands lack rivers and lakes. Water comes from rain stored in reservoirs and natural sinkholes. City like Tikal had an elaborate water management system with plastered plazas designed to channel runoff into storage tanks. But the system had limits. A drought lasting more than 1 or 2 years would exhaust reserves. A drought lasting a decade would be existential. The evidence for drought is strong, but drought alone may not explain everything. The Maya had survived droughts before. The Preclassic period saw dry spells without urban collapse. Why was the 9th century different? One answer is population. By the late Classic period, the Maya lowlands were densely populated. The LiDAR survey suggests 10 million or more people living in the region. This was far more than the Preclassic period. The system was running closer to capacity. There was less margin for error. Another answer is environmental degradation. Centuries of intensive agriculture had depleted soils. Deforestation for construction, fuel and lime plaster production had altered local climate. Erosion was widespread. The Maya had transformed their landscape, but the transformation had costs. The environment that supported the cities was exhausted. A third answer is political fragmentation. The classic Maya world was divided among dozens of competing kingdoms. Wars were constant. The inscriptions celebrate victories, captured enemies, ritual sacrifices. This endemic warfare may have prevented the coordinated response that drought and environmental stress required. Instead of cooperating, the cities competed. Instead of sharing resources, they fought over them. The combination was deadly. Drought stressed the system. Environmental degradation reduced resilience. Warfare prevented cooperation. The cities, which had concentrated population and political power, became liabilities rather than assets. The people left. But where did they go? The archaeological record provides clues. Population did not simply vanish. It dispersed. Some moved to the coasts where fishing and trade provided alternatives to rain-fed agriculture. Some moved to the highlands of Guatemala, where altitude and different rainfall patterns offered refuge. Some moved to the northern Yucatan, where cities like Chichen Itza and later Mayapan continued to flourish. The pattern suggests rational decision-making. People assessed their circumstances and chose new locations. They did not die passively. They acted. They survived. This reframing changes the story. The collapse was not a failure of the Maya. It was an adaptation. The classic period urban system stopped working, so the Maya stopped using it. They developed new forms of organization, new settlement patterns, new ways of life. The cities were abandoned because cities no longer made sense. The political system that had concentrated power in divine kings broke down. The religious ideology that had sustained pyramid building and monument carving lost credibility. The people walked away from a system that no longer served them. Some researchers see this as a form of social revolution. The commoners who had built the pyramids and fed the armies and bled on the altars finally rejected the system that exploited them. They stopped supporting the kings. They stopped providing labor tribute. They stopped believing in the divine right of rulers to command their lives. This interpretation is speculative. We have no inscriptions from commoners. The voices that come down to us are royal, elite, official. But the silence of the commoners is itself evidence. They stopped building monuments. They stopped carving inscriptions. They stopped maintaining the infrastructure of classic Maya civilization. Their rejection was written in absence. The collapse, then, was not collapse. It was revolution. It was adaptation. It was the end of one system and the beginning of another. The Maya who emerged from the transformation were different from their classic period ancestors. They were less centralized, less hierarchical, less monumental. But they were still Maya. They still spoke Maya languages. They still practiced Maya religions, adapted and evolved. They still farmed maize and built communities and raised families. When the Spanish arrived in the 16th century, they found Maya kingdoms still functioning. The cities were different, smaller, less impressive than the abandoned ruins in the jungle, but they were real. They had armies and markets and political structures. The Maya had not disappeared. They had changed. The Spanish would impose their own catastrophe. Disease would kill millions. Conquest would destroy political autonomy. Colonial rule would suppress language and religion. The Maya would suffer terribly, but they would survive, as they had survived the 9th century collapse. Today's Maya are the heirs of this resilience. 7 million people, 30 languages, a continuous cultural tradition stretching back 3,000 years or more. The civilization that supposedly collapsed is still here. This perspective should inform how we think about the ancient Maya. They were not a failed experiment. They were not a cautionary tale of overreach and collapse. They were a successful civilization that lasted for millennia, adapted to changing circumstances, and persists today. The abandoned cities are not gravestones. They are relics of one phase of a longer story. The phase ended. The story continued. But the mystery of the 9th century remains compelling. Even if collapse is the wrong word, something dramatic happened. Cities that had functioned for 500 years stopped functioning. A political system that had organized millions of people disintegrated. The change was rapid and thorough, understanding why matters, not just for Maya history, but for our own time. We live in a world of environmental stress, political fragmentation, and overpopulation. The Maya faced similar pressures. Their response offers lessons. They adapted. They moved. They let go of. systems that no longer worked. They did not die fighting to preserve the old order. They built something new. Whether this was wisdom or desperation, we cannot know. Perhaps they had no choice. Perhaps the collapse was more painful than the archaeological record suggests. Perhaps the transition involved suffering we can only imagine. But the outcome is clear. The Maya survived. They are still here. The collapse that never was. The transformation that succeeded. The people who refused to disappear. In the next chapter, we return to the technology that revealed the full scale of Maya achievement. LiDAR, lasers from the sky, piercing the jungle canopy, uncovering cities invisible for 1,000 years. What LiDAR revealed changed everything we thought we knew. The discovery is ongoing. The jungle is still giving up its secrets. Let us see what lies beneath the trees. Chapter 8. What LiDAR revealed. Imagine you could strip away the jungle, not with machetes and months of labour, not with bulldozers and environmental destruction, but with light itself. Laser pulses fired from an aircraft, millions of them per second, passing through gaps in the canopy, bouncing off the forest floor, returning to sensors that record their journey with millimetre precision. This is LiDAR, light detection and ranging, and it has revolutionised Maya archaeology. The technology is not new. LiDAR has been used for decades in surveying, mapping, and industrial applications. What is new is its application to archaeology, particularly in tropical forests where traditional survey methods are slow, expensive, and physically dangerous. The Maya lowlands are among the most challenging environments on Earth for archaeological fieldwork. The jungle is dense, visibility on the ground is measured in meters. Terrain that appears flat from satellite imagery is actually corrugated with ancient structures hidden under vegetation. A researcher can walk within feet of a pyramid and not see it. Traditional archaeology in this environment proceeds by brute force. Teams cut transects through the forest, recording what they find. They clear vegetation from promising mounds and excavate. Progress is measured in seasons, in years, in careers. A lifetime of work might map a single city centre, leaving the surrounding territory unexplored. LiDAR changed the equation. A single overflight can survey hundreds of square miles. The laser pulses pass through leaves and branches, finding their way to the ground. When millions of returns are combined, the forest floor emerges in stunning detail. Structures invisible from the air become visible in the data. The landscape reveals its secrets. The first major Maya LiDAR surveys came in the early 2000s. Pilot projects at sites like Caracol in Belize demonstrated the technology's potential. Archaeologists who had spent decades mapping Caracol on foot suddenly saw their work extended in weeks. Structures they had missed appeared in the data. The city was far larger than anyone had realized, but the 2018 Pacunum survey in Guatemala was something else entirely. This was not a pilot project. This was a systematic survey of over 800 square miles of the Petén, the heartland of classic Maya civilization. The results were staggering. 60,000 previously unknown structures. 60,000. Pyramids, platforms, houses, walls, roads, reservoirs, agricultural terraces, an entire civilization hidden under the canopy. The numbers forced a radical revision of Maya demographics. Previous estimates had suggested 1 to 2 million people living in the Maya lowlands at the Classic period peak. The new data suggested 10 million or more. This was not a scattered collection of city-states. This was a continuous, interconnected urban landscape comparable to the densest populations of the ancient world. The infrastructure was equally impressive. Raised causeways connected major centres, some stretching for miles through swampy terrain. These sac biob, or white roads, were engineering achievements in their own right. They required planning, labour, and maintenance. They implied political coordination across large areas. Defensive fortifications appeared throughout the survey area. Walls, ditches, and berms protected urban cores. Some complexes showed evidence of sophisticated military architecture, with killing zones and overlapping fields of fire. The Maya were not only builders, they were warriors, and their warfare was more organised than previously thought. Agricultural features covered the landscape. Terraces climbed hillsides, preventing erosion and expanding arable land. Drained fields appeared in low-lying areas, converting swamps to productive farmland. Irrigation channels directed water where it was needed. The Maya had transformed their environment on an industrial scale. Perhaps most striking was the evidence of continuous occupation. The survey area was not a collection of isolated cities separated by empty forest. It was a filled landscape. Everywhere the LiDAR looked, it found structures, small platforms that may have been houses, agricultural features that may have been fields. The entire region had been occupied, worked, modified. This finding upended decades of assumptions. The jungle between Maya cities was not wilderness. It was suburbs, farmland, managed forest. The urban cores were just the most visible manifestation of a civilization that covered the landscape. The implications for Maya society are profound. A population of 10 million requires organization. It requires food production at scale. It requires water management, waste management, conflict management. The Maya were operating systems of extraordinary complexity, and they did it without the advantages that Old World civilizations enjoyed. No metal tools, no draft animals, no wheeled transport. Every stone moved by human muscle, every field cleared by human labor, every road built one basket of fill at a time. The LiDAR data does not explain how the Maya achieved what they achieved. It simply documents that they achieved it. The explanation remains a matter of interpretation. The surveys have continued since 2018. New areas have been scanned, new discoveries have emerged. The Maya landscape is revealing itself piece by piece, and each piece adds to our understanding. In 2020, researchers announced the discovery of a massive platform at the site of Aguada Phoenix in Mexico. The structure is nearly a mile long and over 30 feet tall. It dates to around 1000 BCE, making it one of the oldest Maya monuments known. It predates the Preclassic fluorescence at El Mirador by centuries. Aguada Phoenix was identified through LiDAR and confirmed by ground survey. Without the aerial technology, it might have remained hidden for generations. The site is in flat, unassuming terrain. There are no dramatic pyramids, no obvious mounds, just a subtle elevation change, invisible from the ground, clear in the LiDAR data. The discovery suggests that Maya monumentality began earlier than previously thought. The civilization did not emerge gradually from simple villages. It burst onto the scene with large-scale construction, coordinated labor, and organized society. The foundations of classic Maya civilization were laid more than 3,000 years ago. Other discoveries have followed. In 2021, researchers identified a previously unknown city in the Petén, near the Mexican border. The site, provisionally called La Corona, shows evidence of a major urban center with pyramids, plazas, and residential compounds. It was invisible from the ground, visible from the air. The pace of discovery is accelerating. As LiDAR coverage expands, as data processing improves, as machine learning algorithms help identify features, the hidden Maya world is coming into focus. We are in the early stages of a revolution in Maya archaeology. But LiDAR has limitations. It shows what is there. It does not explain what things mean. It cannot read inscriptions or date structures or determine who lived where. It provides a map, not a history. The map requires interpretation. A platform in the LiDAR data might be a house or a temple or a warehouse or something else entirely. Archaeologists must still go to the ground, still excavate, still analyze artifacts and architecture. LiDAR accelerates discovery. It does not replace the hard work of understanding. There are also ethical questions. LiDAR surveys generate detailed maps of archaeological sites. Those maps could guide looters as easily as researchers. The locations of unexcavated structures are valuable information. In a region plagued by looting, the release of LiDAR data requires careful consideration. The relationship between foreign researchers and local communities is complex. The Maya heritage belongs to the Maya people. LiDAR. Surveys conducted by international teams must navigate questions of access, permission, and benefit sharing. Who owns the data? Who decides what is published? Who profits from the discoveries? These questions have no easy answers, but they must be asked. The technology that reveals the past also raises questions about the present. How we use LiDAR data reflects our values and priorities. What is clear is that the Maya world was far larger, far more complex, and far more impressive than previous generations realized. The LiDAR revolution has rewritten the textbooks. It has challenged assumptions. It has opened new questions even as it answered old ones. The jungle is finally giving up its secrets. After 1,000 years of silence, the cities are speaking again. Not in words, but in shapes. Not in inscriptions, but in infrastructure. The patterns of platforms and plazas, roads and reservoirs, houses and fortifications tell a story of ambition, achievement and adaptation. We are only beginning to read that story. The surveys continue, the discoveries multiply. Each year brings new data, new interpretations, new mysteries. The Maya landscape was not empty, it was full of people, full of buildings, full of effort and organization. What we see in the ruins was never the whole picture. The whole picture was hidden under the trees. Now we can see it, and what we see changes everything. The lasers have spoken, the canopy has parted, the cities of the Maya stand revealed. In the next chapter, we return to the question that has haunted this entire investigation, the ancient astronaut debate. The claims of outside influence, extraterrestrial contact, knowledge that should not exist. We have examined the evidence. We have considered the arguments. Now we must render a verdict. Were the Maya visited by beings from beyond Earth? Did they receive knowledge from an advanced civilization, human or otherwise? Or is their achievement fully explicable in human terms? The ancient astronaut debate. Let us engage it directly. Chapter 9. The ancient astronaut debate. Let us be direct. The ancient astronaut hypothesis, as applied to the Maya, makes specific claims. It argues that Maya achievements, particularly their astronomical knowledge, cannot be explained by conventional means. It suggests that the Maya received assistance from extraterrestrial beings. It interprets certain Maya artifacts and images as evidence of advanced technology. These claims deserve serious examination, not mockery, not dismissal. Examination. If the evidence supports them, we should follow where it leads. If the evidence does not support them, we should say so clearly. Either way, the Maya deserve honest analysis, not ideological warfare. So let us examine the claims one by one. Claim 1. Maya astronomical knowledge is too precise to have been developed through naked eye observation alone. The evidence offered includes the Venus tables in the Dresden Codex, which track the synodic period of Venus with an error of less than 2 hours over 584 days. It includes the calculation of the solar year as 365.2420 days, accurate to within 30 seconds per year. It includes eclipse prediction, planetary tracking, and the integration of multiple cycles over centuries. This precision is genuinely impressive. But is it impossible without outside help? The answer is no. Naked eye astronomy, practiced systematically over centuries, can achieve remarkable precision. The Maya were not guessing. They were measuring. They were recording. They were calculating. Consider how they might have done it. A priest stands at a fixed observation point. He watches the horizon. Each morning he notes where the sun rises. Each evening he notes where it sets. He marks the position against stone pillars or natural features. He records the date in the long count, day after day, year after year, generation after generation. Over time, patterns emerge. The sun rises at its northernmost point on one day each year. This is the summer solstice. It rises at its southernmost point on another day. This is the winter solstice. The days in between can be counted. The length of the year becomes clear. The same method applies to Venus. Watch where it rises, watch where it sets. Record the dates. Note when it disappears behind the sun. Note when it reappears. Count the days between events. Over decades of observation, the synodic period becomes clear. The precision improves with time. If one generation gets a value of 585 days, the next generation refines it to 584. Errors accumulate and become visible. Corrections are made. The tables are updated. This is not magic. It is science. It is the same method that Babylonian astronomers used to predict eclipses. It is the same method that medieval Arab astronomers used to refine Greek data. Patient, observation, careful recording, mathematical analysis. The Maya had centuries to do this work. They had cultural institutions dedicated to astronomical observation. They had a writing system capable of recording complex calculations. They had the long count calendar to correlate observations separated by generations. Given these resources, the precision of Maya astronomy is remarkable, but not inexplicable. It is the product of sustained intellectual effort, not extraterrestrial intervention. Claim 2. Maya mythology describes beings from the sky who brought knowledge and civilization. This is true. Maya creation myths, particularly the Popol Vuh, describe gods who created humanity and taught the arts of civilization. These gods are sometimes associated with celestial phenomena. They come from above. They possess knowledge that humans lack. But this pattern is universal. Every culture has origin myths. Every culture attributes its foundations to supernatural beings. The Greeks had Prometheus bringing fire. The Egyptians had Thoth bringing writing. The Sumerians had the Anunnaki establishing kingship. The Chinese had the sage emperors teaching agriculture and medicine. These myths encode cultural values and explain cultural origins. They are not literal history. They are narrative frameworks for understanding human existence. To interpret Maya myths as evidence of extraterrestrial contact requires assuming that Maya myths are different from all other myths, that they alone record actual events, that the Maya, unlike every other culture, were visited by real beings from space. This is special pleading. It applies one standard to the Maya and another standard to everyone else. There is no methodological justification for this. The gods in Maya mythology behave like gods in mythology everywhere. They are powerful. They are sometimes benevolent, sometimes cruel. They create and destroy. They demand sacrifice. They are not described as beings from another planet. They are not said to travel in spacecraft. The astronomical associations reflect the Maya understanding of the cosmos, in which the sky is the realm of the divine. Reading alien visitation into these myths requires reading in, not reading out. It requires importing modern concepts that the Maya themselves would not have recognized. Claim 3. Maya iconography depicts advanced technology, particularly spacecraft. The primary exhibit is the sarcophagus lid of Pakal, which we examined in detail in Chapter 4. We concluded that the conventional interpretation, depicting Pakal's descent into the underworld, is well supported by evidence. The astronaut interpretation requires ignoring Maya symbolism and projecting modern expectations onto ancient art. Are there other examples? Ancient astronaut proponents point to various Maya images that allegedly show astronauts, rockets, or advanced machines. Let us consider some. The Mayan helicopter at Abydos is sometimes cited, but Abydos is in Egypt, not Mesoamerica, and the so-called helicopter is a palimpsest, overlapping inscriptions that create coincidental shapes. It has nothing to do with the Maya. Some point to figurines and carvings that allegedly show beings in spacesuits or helmets. Upon examination, these typically show priests in ritual regalia, warriors in battle dress, or supernatural beings in traditional costume. The Maya had elaborate ceremonial clothing. Headdresses, masks, and body adornment were complex and visually striking. To modern eyes, unfamiliar with Maya costume, these can look strange. But strangeness is not evidence of extraterrestrial origin. The Temple of the Inscriptions at Palenque, beyond Pakal's tomb, contains no depictions that cannot be explained by Maya religion and politics. The other great Maya sites, Tikal, Calakmul, Chichen Itza, Uxmal, contain no images that require technological interpretation. The iconographic evidence for ancient astronauts is weak. It depends on selective interpretation, unfamiliarity with Maya art, and a willingness to see what one expects to see. Claim 4. The Maya could not have built their cities without advanced technology. This claim misunderstands what the Maya actually did. Maya construction used available materials, primarily limestone, worked with stone tools. Limestone is relatively soft when freshly quarried and hardens with exposure to air. It can be cut, shaped, and carved with obsidian, chert, and other stone implements. The Maya did not need metal tools. They had something better for their purposes. Obsidian, volcanic glass, holds an edge sharper than surgical steel. It is abundant in highland Guatemala, and trade networks brought it to the lowlands. Obsidian blades could cut stone, carve wood, and perform surgery. Maya construction techniques are well understood. Buildings were made of rubble cores faced with cut stone. Corbelled arches, though limited compared to true arches, allowed the spanning of interior spaces. Lime plaster provided waterproofing and decorative surfaces. None of this required technology beyond what the Maya possessed. The labor required was immense, but the Maya had labor. Populations in the millions could mobilize tens of thousands of workers for royal construction projects. The pyramids were not built in a day. They were built over years, even decades, by organized teams working under royal direction. Comparisons to Egyptian pyramids are instructive. The Great Pyramid of Giza was built with bronze tools, copper saws, and wooden sledges. The Egyptians had no wheel, no draft animals in the sense of oxen or horses, no cranes. Yet they built the largest stone structure of the ancient world. Human organization and persistence can achieve extraordinary things. The Maya achievement is no more mysterious than the Egyptian achievement. Both cultures mobilized massive labor forces over long periods to build monuments that expressed political and religious power. Both did it with the technology available to them. Claim 5. The Maya disappeared mysteriously, suggesting external factors. We addressed this in Chapter 7. The Maya did not disappear. They transformed. The classic period urban system collapsed, but the Maya people survived. 7 million Maya live today. The civilization continues. The causes of the 9th century transformation are debated, but not mysterious. Drought, environmental degradation, warfare, and political fragmentation combined to undermine the urban system. People adapted by dispersing, moving, and developing new forms of organization. There is nothing in the collapse that requires extraterrestrial explanation. It follows patterns seen in other civilizations that have faced environmental and political stress. The Roman Empire collapsed. The Harappan civilization collapsed. The Akkadian Empire collapsed. None of these collapses are attributed to aliens. Having examined the specific claims, what can we conclude? The ancient astronaut hypothesis, as applied to the Maya, fails on the evidence. Maya achievements are impressive but explicable. Maya mythology follows universal patterns. Maya iconography depicts Maya culture, not alien technology. Maya construction used available materials and massive labor. Maya transformation reflects environmental and political factors. This does not mean the Maya were not remarkable. They were. Their achievements in astronomy, mathematics, architecture, and art are genuinely extraordinary. They developed a sophisticated civilization in a challenging environment without the technological advantages of old world cultures. But their achievements were human achievements. They did not require outside help. Attributing them to extraterrestrials diminishes rather than enhances Maya accomplishment. It says, in effect, that indigenous Americans could not have done this on their own. That is not only wrong, it is insulting. The ancient astronaut hypothesis often carries this undertone. It attributes the achievements of non-European civilizations to outside intervention, while accepting European achievements as indigenous. The pyramids of Egypt require aliens. The pyramids of Mexico require aliens. But the cathedrals of Europe do not. The bias is clear. Rejecting the ancient astronaut hypothesis does not mean rejecting mystery. The Maya remain mysterious in many ways. We do not fully understand their origins. We do not fully understand their collapse. We do not fully understand their religion, their politics, their daily life. The questions are genuine. But genuine questions deserve genuine investigation. They deserve archaeological excavation, epigraphic analysis, scientific testing. They do not deserve speculation dressed as revelation. They do not deserve claims unsupported by evidence. The Maya deserve to be understood on their own terms, as a human civilization, as an indigenous achievement, as a living culture that persists today. The ancient astronaut debate is, in the end, a distraction. It focuses attention on fantasy when reality is far more interesting. The real Maya, the ones we are discovering through LiDAR and excavation and linguistic analysis, are more fascinating than any alien visitation could be. They built cities in the jungle. They tracked the stars across millennia. They created art of stunning beauty. They developed mathematics that surpassed their European contemporaries. They survived conquest, disease, and colonization. They are still here. Asking whether they needed alien help misses the point entirely. The Maya did this. Humans did this. That is the wonder. That is the mystery worth contemplating. In our final chapter, we turn to the living Maya, the people who carry this heritage forward. What do they know that we do not? What have they preserved across the centuries? What can they teach us about their ancestors and ourselves? What the Maya still know. Chapter 10. What the Maya still know. In the highlands of Guatemala, in villages scattered across the mountains, the Tzolk'in calendar still turns. Daykeepers, traditional spiritual specialists, track the 260-day cycle that their ancestors created thousands of years ago. They know which days are auspicious for planting, for marriage, for travel. They perform ceremonies on the sacred dates. They maintain a continuous tradition that predates the Spanish conquest by millennia. The Maya are not a vanished people. They are not a mystery to be solved by outsiders. They are 7 million people living their lives, speaking their languages, practicing their traditions. What they know about their ancestors is not speculation. It is inherited memory, passed down through generations, preserved in ritual and story and everyday practice. This living tradition is often overlooked in discussions of ancient Maya civilization. Researchers focus on ruins and inscriptions, on archaeology and epigraphy. These are valuable sources, but they are not the only sources. The Maya themselves have knowledge that the stones cannot provide. Consider the Tzolk'in. When Spanish missionaries arrived, they tried to suppress Maya religion. They burned books, they destroyed idols, they imposed Christianity, but they could not stop the day count. The Tzolk'in continued, passed from generation to generation in oral tradition, maintained by daykeepers who risked punishment to preserve it. Today, ethnographers have documented the Tzolk'in as practiced in highland Guatemala. The day names vary slightly from community to community, but the structure is consistent with ancient inscriptions. The calendar that modern Maya use is the same calendar that appears in classic period monuments. The count has not been broken. This continuity is remarkable. 500 years of colonization, political upheaval, and cultural suppression did not destroy the tradition. The Maya preserved their calendar because it mattered to them. It was not an abstract intellectual exercise. It was a living practice, woven into the fabric of daily life. What can the living Maya tell us about their ancestors? They can tell us about worldview. The Maya understanding of time, space, and the cosmos persists in traditional communities. Time is not linear, it is cyclical, events recur. The past informs the future. This perspective, which we glimpse in ancient inscriptions, is still alive in Maya thought. They can tell us about agriculture. Traditional Maya farming practices, particularly the milpa system of rotating maize cultivation, have been maintained for centuries. Modern research confirms that these practices are ecologically sophisticated, maintaining soil fertility and biodiversity in ways that industrial agriculture does not. The Maya knew their environment intimately. That knowledge survives. They can tell us about medicine. Traditional Maya healers use plants and rituals that have pre-Columbian roots. Some of these practices have proven pharmacologically effective. Modern researchers have documented Maya herbal remedies that contain genuine therapeutic compounds. The ancestors understood their environment, and that understanding was not purely spiritual. They can tell us about craft. Maya weavers still produce textiles using techniques that date back centuries. The patterns encode meaning. The colours carry symbolism. The act of weaving is not just production, it is cultural transmission. Each textile is a document of Maya identity. They can tell us about resistance. The Maya survived conquest. They survived colonization. They survived civil war and genocide. The resilience of Maya culture is not an accident. It is the product of deliberate effort, of communities that chose to maintain their identity despite overwhelming pressure to abandon it. This resistance continues. In Chiapas, Mexico, the Zapatista movement draws on Maya identity and tradition. In Guatemala, Maya activists fight for language rights and cultural recognition. Across the Maya world, communities organize to protect ancestral lands, preserve traditional knowledge, and assert their place in modern nations. The Maya are not a museum exhibit. They are a living people with a living culture facing contemporary challenges. Understanding the ancient Maya means understanding this continuity. The pyramid builders are not gone. Their descendants are here. But the relationship between ancient and modern Maya is complex. 5 centuries of colonization have left deep marks. Languages have merged with Spanish. Religions have blended with Catholicism. Political structures have been transformed by state power. The Maya of today are not identical to the Maya of the classic period. This does not make them less authentic. Culture is not a fossil. It evolves, adapts, changes. The Maya of today are as Maya as their ancestors, even though their lives are different. Identity is not frozen in time, it is lived in the present. Some traditions have been lost. The hieroglyphic script was not preserved. The Maya of today cannot read the inscriptions their ancestors carved. When epigraphers deciphered the script in the 20th century, they were recovering knowledge that had been lost to the Maya themselves. This loss is painful. It is a consequence of conquest, of book burning, of cultural suppression. The knowledge that Spanish friars destroyed can never be fully recovered. We have fragments, we have inference, we have the stones, but the libraries are gone. Yet the Maya response to this loss has been remarkable. As decipherment progressed, Maya communities engaged with the results. Schools began teaching hieroglyphic reading. Artists incorporated ancient imagery into contemporary work. Activists used the recovered history to strengthen claims to land and rights. The relationship between archaeologists and Maya communities is evolving. For decades, outsiders studied the Maya as objects. The Maya were not consulted about interpretations. Their perspectives were not considered relevant. The ancient and modern Maya were treated as separate categories. This is changing. Collaborative archaeology involves Maya communities in research design and interpretation. Maya scholars contribute to academic debates. Indigenous perspectives are recognized as valuable, not just politically, but intellectually. The Maya themselves are rediscovering their heritage. Young people learn hieroglyphics that their grandparents never knew. Communities reclaim sites that colonizers had declared abandoned. The past becomes a resource for the present, not a burden, but a foundation. What do the Maya still know? They know who they are. Despite centuries of pressure to assimilate, to disappear, to become something else, the Maya have maintained their identity. This persistence is itself knowledge. It is the knowledge of how to survive, how to adapt, how to preserve what matters while accepting what must change. They know their land. The Maya relationship with the environment is intimate and detailed. Traditional ecological knowledge, accumulated over millennia, informs agriculture, medicine, and resource management. This knowledge is increasingly recognized as valuable as industrial approaches prove unsustainable. They know their stories. Maya oral tradition preserves narratives that illuminate the ancient past. The Popol Vuh, recorded after the conquest, clearly draws on older sources. Other stories, less famous but equally precious, circulate in communities where elders pass them to the young. These stories are not just entertainment, they are philosophy, history, and survival strategy. They know their obligations. Maya cosmology emphasizes reciprocity. Humans owe debts to the gods, to the ancestors, to the earth. These debts must be paid through ritual, through respect, through proper living. This ethical framework has sustained Maya communities through immense hardship, and they know their future. Maya activists and intellectuals are articulating visions for Maya communities in the 21st century. They are not seeking to recreate the classic period. They are seeking to carry Maya identity forward, adapted to modern realities grounded in traditional values. The Maya civilization that began 3,000 years ago continues. It has changed. It will keep changing. But the thread remains unbroken. The people who built El Mirador and Tikal and Chichen Itza have descendants who remember them, who honor them, who carry them forward. This is the final lesson of Maya civilization. It is not dead. It is not a cautionary tale. It is not a mystery to be solved by outsiders. It is a living tradition, maintained by living people looking toward a living future. The jungle still holds secrets. LiDAR will reveal more cities. Archaeologists will excavate more tombs. Epigraphers will read more inscriptions. Each discovery will add to our understanding of the ancient Maya. But the Maya themselves are the greatest source. 7 million people, 30 languages, traditions that stretch back millennia. The ancestors built cities that rivaled any on Earth. The descendants maintain an identity that colonization could not destroy. The Maya tracked the stars, they built pyramids, they created calendars that count forever. They survived conquest, collapse, and colonization. They are still here. When we ask what the Maya knew, we should also ask what the Maya know. The answers are not only in the stones, they are in the people. They are in the language, the ritual, the memory, the persistence. The Maya story is not over. It continues as the long count continues, cycling through ages, marking time, carrying meaning forward. The calendar counts forever. The Maya endure. If you enjoyed this deep dive into Maya civilization, please like this video and subscribe to the channel. Your support makes these investigations possible. Tell me in the comments, which ancient mystery should we explore next? The Nazca lines of Peru, the megaliths of Göbekli Tepe, the underwater structures of Yonaguni, the lost libraries of Alexandria. Every civilization has secrets. Every ruin has a story. The past is waiting to be discovered. Thank you for watching. I will see you in the next investigation.